earliest opportunity once operational orbit has been reached.
After its release from the spacecraft, the retro rocket of MIP will be fired and it will slowly start its descent to the lunar surface. During the descent, MIP's video imaging system will acquire images of the surface of the Moon. The mass spectrometer will measure the constituents of thin lunar atmosphere, and the radar altimeter will provide instantaneous altitude and hence give inputs for future Indian soft landing missions. Thereafter, MIP will impact on an identified area in the south polar region of Moon.
The payloads on Chandrayaan-1 are engineered to acquire scientific information on the Moon through remote sensing in the visible, near-infrared, microwave, low and high-energy X-ray regions of the electromagnetic spectrum. The selenological mapping will identify different features on the surface of the Moon and will help us understand the different layers of the Moon's crust. TMC and LLRI will carry out topographic mapping of the lunar surface.
TMC will take three-dimensional black and white imagery of the lunar surface with a resolution of about 5 meters. LLRI will provide accurate altitude or height information of the spacecraft above the lunar surface for topography and gravity mapping.
The chemical mapping of the lunar surface will help us in understanding the formation and evolution of the Moon, as well as in finding out the possibility of lunar mining for precious elements. 6 and HEX will carry this out.
6 will measure fluorescent X-rays coming from the Moon from lighter elements like magnesium, aluminium, silicon, calcium, and iron. On the other hand, HEX will map the heavier radioactive elements like uranium, thorium, and lead.
High-resolution maps revealing mineral composition will help us in understanding the early evolution of the Moon, provide information on lunar resources, and support the planning of future missions. HiSci, SIR-2, and M3 will provide these maps.
HiSci will rely on the visible and near-infrared rays reflected from the Moon and will slice the incoming light into 64 parts to observe many specific details. SIR-2 will help to analyze lunar surface and to study the vertical distribution of lunar crustal material. Besides, it investigates the process of basin, maria, and crater formation on the Moon, and it will survey Moon's mineral resources. Similarly, M3 will explore lunar mineral composition in the context of Moon's evolution.
Radome will measure the nature and composition of the radiation in the vicinity of the Moon. This data will help us in assessing the radiation shielding requirements for future human missions.
Radome will qualitatively and quantitatively measure the particle flux, deposited energy spectrum, accumulated absorbed dose rates in lunar orbit.
SARA will be the first ever energetic neutral atom imaging mass spectrometer to be used for planetary exploration.
Using low-energy neutral atoms, SARA will image the lunar surface composition and magnetic anomalies, along with studying the solar wind surface interactions and space weathering.
With the aim of searching for water ice, MINISAR will map the permanently shadowed regions of the lunar poles up to about a meter's depth.
The payload has an onboard radar mapper that will allow viewing of all permanently shadowed areas on the Moon.
Along with MINISAR, SARA, SIR-2, M3 and HEX will investigate the presence of ice on the Moon. All this scientific data collected by the payloads, as well as the statecraft's health and orientation, will be collected on 3 onboard solid-state recorders or SSRs. This information will come to us through a complex network initiated by dual gimbaled antenna on the spacecraft.
The dual gimbaled antenna of Chandrayaan-1 spacecraft will track the ground stations using the onboard computer when the spacecraft is in lunar orbit. Operating in X-band, this antenna will transmit information gathered by the spacecraft's scientific instruments. Indian Deep Space Network antennae situated at Bailalu, along with Deep Space Network antennae, will receive this precious data, which will be later sent to Indian Space Science Data Center ISSDC situated at Bailalu. ISSDC will act as the storehouse of information gathered by Chandrayaan-1 spacecraft and facilitates science data processing, archival, retrieval and dissemination of that valuable information for both Indian and foreign scientists. The facilities established at ISSDC will cater to the needs of Chandrayaan-1 and other science missions that will follow.
Chandrayaan-1 will orbit the Moon for 2 years, during which it will continuously send us scientific data. Earlier, the Moon was considered an inactive celestial body. Now we know that it is a rich storehouse for resources like helium-3. If found in abundance, helium-3 can be a non-polluting energy resource for our future.
Scientists are now planning lunar bases where astronauts will live and work for months at a time. Since lunar gravity is quite less in comparison to Earth, Moon can be used as a platform for launching interplanetary missions as well. The water ice on Moon has probably come from comets that crashed into the Moon long ago. It can be either melted to supply a future Moon base with water, or broken down into oxygen for astronauts to breathe and into hydrogen that can serve as rocket fuel. The presence of hydrogen or water will pave way for establishing bases on the Moon and use it as a platform to observe the sky by installing a telescope on its far side. India's first mission to the Moon, Chandrayaan-1, provides ISRO an unprecedented opportunity for learning and gaining expertise in newer fields of space science and technology, like deep space navigation and communication. It also allows us to acquire expertise in the development of instruments and the more sophisticated project management involving international space agencies required for future planetary exploration programs. For the first time, ISRO is all set to go beyond the Earth's orbit into the deep space of interplanetary missions.
3, 2, 1, 0, +1, +2, +3.
Chandrayaan-1 emphasizes India's commitment to human quest for understanding our universe through space exploration.
Chandrayaan-1 is the culmination of years of hard work and the excellence of Indian scientists, with inputs from scientists across the world. It is an excellent illustration of teamwork and knowledge sharing, a feather in the cap of Indian scientists and a matter of great pride for every Indian. Chandrayaan-1 is India's first passage to the Moon. There are many more to come that will go deeper into outer space.